So we want to evaluate this limit. The limit as x approaches 0 of the cube root of 1 plus x squared minus the 4 root of 1 minus 2x, all divided by x plus s squared as x approaches 0. Now upon direct substitution, you are going to have 0 or 0 for this limit. But we know that that is one of the indeterminate forms. So we have to evaluate this limit. What do? I'm going to use series to evaluate the limit. And for the series, I'm going to say note that each time you have 1 plus x raised to the power of n, that's 1 plus nx plus n times n minus 1 over 2 factorial x squared plus, and then you continue like this, n times n minus 1 times n minus 2 over 3 factorial s cubed, and so on. So I'm going to use that for this. So I'm going to write the limit of 1 plus x squared all raised to the power of 1 over 3 minus 1 minus 2x all raised to the power of 1 over 4 all divided by, I can factor an s from here, I'll have x, I'll have 1 plus x. X approaches 0. So this, if I compare this to this, 1 is here, 1 is here. This x in this case is s squared and n is 1 over 3. Here we have this 1 and then x in this case is negative 2x and then n is 1 over 4. So I'm going to have the limit as x approaches 0 of this one, 1 plus nx. So it's 1 plus n. What is n? N is 1 over 3. And what is x? X is x squared. 1 plus nx, that's what you have here. Now, you go on to these, but these are not really important because the rest of the other ones will go to 0. So they're not important. So we have plus dot dot dot, and then I have minus. I do this, I'll take the first two terms, 1 plus, your n is 1 over 4 times x is negative 2x plus dot dot dot, all divided by x times 1 plus x. Remember, I did not take the third term because the third term will go to 0 after you've completed it. From here, we can apply this expansion right here. We apply this expansion, so we have the limit. From here we have 1 plus nx according to the expansion. So you have 1 plus, the n is the power of the entire expression, so it's 1 over 3, and the x is s squared, so 1 over 3 s squared plus. Now you take the third term, it will go to 0, so I'm just going to stop right here to where we have x squared, and then minus, you apply this expansion on this, you have 1 plus nx, so it's plus, n is 1 over 4, and x is negative 2x, plus dot dot dot. So if you do that, all divided by x times 1 plus x. So if you do that, what will you have? We realize that this negative will fit everything here, so we have the limit of 1 plus, this becomes x squared over 3 plus dot dot dot, and then minus 1. Negative times negative is positive. If you simplify this, you have x over 2 plus dot dot dot, all divided by x times 1 plus x as x approaches 0. So all we have there, this positive 1 and this negative 1 are going to cancel out. So I'm going to have this and this going out, and then we only have x over 2. So we have the limit of x over 2, and then plus s squared over 3 plus dot dot dot, all divided by x times 1 plus x as x approaches 0. Good. Now once we do that, we can factor out an x from the numerator. So we have the limit of x. This will give you 1 over 2 plus, this will give you x over 3, all divided by x parenthesis will be 1 plus x as x approaches 0. So what you realize here is that this x and this x are going to cancel out, so you're just going to have the limit of 1 over 2 plus x over 3 all divided by 1 plus x as x approaches 0. So this is now undefined. So remember this dot 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 continues right here. So I'm just going to rewrite it. And then it continues here. If I apply direct substitution, all of these expressions that have a dot 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 are going to go to 0. So I'm going to have 1 over 2 plus 0 over 2 all divided by 1 plus 0. And this is going to give me 1 over 2 all divided by 1. They just half. So the result of that limit is half. Thank you for watching and see you in the next video.